All right, let's talk about tuning this DX-100 up. So we start, we're going to have audio gain down to 0, your drive down very low. Pick the band you want for today's demonstration. I use 40 meters. I'm going to bring the loading down, plate off, put it in CW mode. The driver position and the amplifier positions will set as we go, and the meter switch into grid. So I'm going to turn it on and give tubes a chance to warm up. Give it a good minute or so. I just had it on, so I had a little jump start on it. So you can run through here, just make sure you don't see anything out of the norm. Basically, driver, grid, plate, the voltage, and the modulator should all be sitting at 0 at this point. We're going to start off in the grid position. Make sure you have a key plugged in. If the key's not plugged in, it's going to key up the rig. It's basically set up that way, so if you don't have a key, you can tune it without the key. And so let's get started here. First thing we want to do is get 5 milliamps worth of grid drive. This is a driver to drive your final amplifier. And with this setup, it needs 5 milliamps. Or they recommend 5 milliamps to drive the amplifier. This driver knob, there is a capacitor across there, and we're actually going to tune it to peak the drive current. Now we have a drive control down here. This is basically a rheostat or a pot that will limit the overall drive current, and down to 0 we're not going to get much there. So I'm going to turn it up just a little bit, and on 40 meters this rig has a lot of drive. You're probably not going to get past 2 without overdriving it. So I'm starting really low, and what we're going to do is we're going to key it. Look here at the driver current. We read that on the bottom scale. It's 0, 2, 4, 6, 8, 10 milliamps. We want to go mid-scale, which is 5 milliamps. So I'm going to key the rig up and find that peak. All right, there's our peak. So the drive circuit is tuned now. Now, we're not putting out any RF at this point, or not putting out any significant RF. The final amplifier is turned off because we've got the high voltage turned off to the plates. So this is a good time to spot your frequency. I've got a receiver here. The receiver VFOs can be a lot more accurate than this one. And let's assume we want to transmit on 7.105 megahertz. And so I know I'm close. I set the VFO to that. So now that I've got some drive current, let's see if we can find it. So I'm going to key the rig. There it is. Very close. Now the fact that I've changed frequency means I need to retweak the drive circuit. So I've peaked my drive. Now I need to add more drive current, and that's what we do back here. This tunes the circuit. This is like a volume control. It adds more, add more current. So I'm going to turn this up until we hit mid-scale. So that's 5 milliamps right there. In fact, if you listen, you can even hear the chirp. You may not be able to hear the receiver. I'll turn it up a bit. That, on the first key there, you heard a dramatic tone change. That was a house air conditioner turning on. So you can see how sensitive the VFO is to voltage changes. and that's what causes these chirps. Okay, so we've got the drive set. Now we need to turn on the final amplifier. So I'm going to put this in the plate position. Notice I key it. I don't get hardly any needle movement. So what we're going to look for is we're going to turn on the plate voltage. Boy, when you do that, you know you've keyed up, or you have put a strain on your power system. So now that the plate voltage is active, what we're going to be looking for is a dip. We need to tune the output circuit for maximum RF transfer. Now, if you have a SWR meter or a power meter that you can actually see the RF output, you want to peak this. If you don't, we want to dip the plate current. We're going to read the plate current in this scale from 0, 10, 20, 30, 40, 50. Those are, multiply that by 10. So our final goal will be 230 milliamps. And it may actually be 240. I don't remember what the book said. I always shoot for 230. So we need to maximize the current RF transfer through the antenna circuit. Get it tuned so we're taking as much power out of the final amplifier tubes and out to the antenna. And you do that. When you do that, you actually minimize the plate current. If we're out of tune, that plate current goes up and the final amplifier vacuum tubes have to eat that additional power. So, and that will shorten the life of these tubes. So we need to dip this plate, and we need to do it fairly quickly with the big picture in the long run, making those final tubes last for many years. My DX-60 is, oh gosh, 45, 50 years old, and I'm only on the second final vacuum tube. So they will last a long time if you treat them nice. So I'm going to key the rig up. I want you to watch here, and then we're going to dip this plate quickly. See how high that went? So now we got our dip, but we're only running 100 milliamps. So what we want to do now is bring the loading up, redip, bring the loading up, redip, until we get the final current at 230 milliamps. So now we're going to bring the loading up and redip. So now the dip is at about 220, so I'm going to bring it up just a tad more, and one more redip. And there you are, 230 milliamps. Now I also come back and check the grid. I notice the grid drive has dropped from 5 milliamps down to 2. I'm going to go ahead and bring that up just a little bit. Just give it a little more drive, maybe 4 milliamps. I run them a little lower just to protect the tubes a bit. Come back to plate. Notice our plate current's a little high because of the more drive. Check the dip, and then I'm just going to lower this loading down to 230. And you're ready to go. Turn it up so you can actually hear the chirping. And that's it. It is tuned up, ready to go. Now, what about phone? What about AM mode? So you've tuned the driver, you've tuned the final amplifier. So for phone, make sure you got your mic connected, and we're going to switch it over to phone mode. And you hear when I do the switch, it sends out the constant carrier. So I'm going to tune my receiver to know that out, since we're on a single sideband receiver and I need to trick it into phone mode, so I need to zero beat that carrier. Then I'm going to put it into modulator and then just speak into the mic and raise the audio gain until we get just a little bit of deflection. If I go any more than this, I'm going to actually get feedback. So I'm going to turn down my receiver just a bit, and right about there, that's all the modulator current you need to see, just to make sure it's actually peaking a little bit. And that's it. Now, you don't want to stay in phone mode a real long time if you're running on a dummy load, because you're really going to heat it up. So I'm going to take this back to CW mode to turn off that carrier. And that's it. That's how you tune it up. Now, the one thing that I missed at the beginning of this video is before we tune the finals, remember when I turned the plate voltage on, I like to put this over here in the plate position, and we should be reading about 830 volts right there. I'm sorry, I said plate position. I meant the volt position. So we're actually reading the high voltage, and you should have about 830 volts. If you see that when you turn this plate voltage on or the high voltage on and you're on the volt scale, if you see that start to fall, then turn the rig off. Your filter capacitors are starting to fail, and you need to fix that. All right, I'm going to key this up one more time. See how the high voltage drops from 830 to 800 volts? That is why your VFO chirps. It can't handle that voltage change without shifting frequency slightly. And not that it's powered off the high voltage, but the overall current of this rig goes up, and it drops the low voltage supplies just a little bit, and that's enough to affect that frequency. So you get the chirp. But that's part of the charm of the old rigs. All right, I'm going to turn the plate voltage off. And if I decide to tune it to a different band, plate voltage off, switch bands, go through the same scenario you went through. Now, one thing about the VFO on this particular rig, 10, 15, 20, and 40 meters is on one VFO circuit. 80 and 160 are on the second VFO circuit. So I know you use 40 a lot. On 40, it's weird, but the VFO dial actually has two 40-meter bands on it. You want the one that is showing when the 10, 15, and 20-meter bands are showing. Since that's all, that VFO is just putting out one frequency for all four of those bands. For 80 meters and 160, you'll even feel the band switch has got another switch in there that will move the VFO to the second circuit. We have to come all the way over here to this part of the dial, which is where you've got your 80 and 160 field. Now, I don't know why they did it, but there they put 40 meters at the very top. Do not use this. This is not in your 40-meter band. If you're on 40 meters, you have to be over here on this part of the dial. It may be hard to see in the video, but you'll see it goes from 7.0, 05, 7.1, 7.2, 7.3. So there's the entire 40 meter band. All right. And just for completeness, the 11 meter BFO is also at separate, and it's right here. But you're not going to use that anyway. So that's about it. And when you're done, power it off. All right. Hope that explains everything. I'll also write these instructions down for you.